Hi everyone, good morning, good afternoon, or good evening, based on wherever you are. Thanks for joining in. Welcome to this DC Core series. Before this, I have been posting videos on what exactly DC Core is about, the whole course in itself, what are the different labs, what are the concepts that you cover in this particular course, and I've also cleared out the whole data center track, like in terms of if what is your career goal, so what should you be choosing as your learning path in order to be a certified professional, in order to be of some value to your company and to your society, and what steps should be taken next in order to be achieving your future goals or career goals. So if you haven't checked that out, I highly recommend you check this out. I will provide the link in the description. Let me know how you feel about it. For today, I will be talking about, and I will be kicking things off with the switching first. So taking STP as my first topic here and everything that revolves around it. So this is going to be a very quick video. Let's jump right in it. First of all, what are we going to cover in this video? We'll talk about why STP matters, different flavors, and specifically I will be talking about rapid PVST plus. Then we have the STP extensions, Cisco enhancements, you can say. Apart from that, we have a couple of features, edge ports, BPDU Guard, and filter, topology protection, how we can protect our topology, what steps should we take next in order to protect the entire, switching topologies, the role of root bridge, and the unidirectional link issues, and how we can prevent them. Let's start with what exactly STP is. So, what exactly STP is all about? It's simple. When you connect switches with redundant links, you create loops. And if not even redundant links, but you have a redundant topology, then still you can create loops. This is where STP steps in. It elects a root bridge and it blocks the extra paths so your network doesn't freak out. And that's the original loop prevention here. So that's the original one. But what exactly are the other flavors? One of the flavors and very famous flavor is Rapid PVST plus. So Cisco is not just like stopping at the classic STP. Rapid PVST is their version. It's their proprietary version. It gives each VLAN its own STP instance, and it's going to converge way quicker. So think of it as STP on a Red Wolf. There are different port roles that we see in this particular flavor of STP. We have root. Well, we do have root in the different flavors too. We have designated, but here we see alternate backup and edge port kind of features here. So let's talk about them. There are certain extensions that Cisco has added. It's like adding spices to the STP. And with these extensions, you see UplinkFast, BackboneFast. What they do is they speed up the recovery process whenever the link goes down. The convergence of the whole topology speeds up. What exactly is then PortFast? PortFast that's used for getting edge ports up in seconds. If you have your system connected to your switches, you don't want to, wait for 30 seconds or 15 seconds in order to get an IP address. You turn your PC on and you should get an IP address as quickly as possible. So STP could be, even though we are talking again about the rapid PST plus, but it could be a hindrance in taking those IP addresses from the DSCP server. So PortFast is going to be super useful at that point, especially in access layers. Coming up next is the edge port. Edge ports are where your end devices like your PCs and servers, they plug in, and when I plug in any of my server or my PC into the switch and I enable PortFast on that switch, that skips that usual STP delay and it starts talking to the network almost instantly. That's very efficient for the end users. So they don't have to again wait for the DSCP requests and failures that we might see. Apart from this one feature, we have BPDU Guard. And there's a catch this. If someone's like actually accidentally, even not even intentionally, plugs in a switch into an edge port, thinking, okay, I have this switch and I have only one, point. I have only one interface that I can use for my PC. Now I have to connect my printer also. I have to connect this and that. So how am I supposed to do that? And he said, okay, let me bring my own switch, and then I will plug in my own switch, and I will have my own, ports. I have like 4 or 8 ports or whatever. What happens? Things can go south because that switch, that new switch, can broadcast the BPDUs, and if by any case that BPDU is lower than the other BPDUs that we have, that are already roaming around in the network. So what happens is that the new switch becomes the root bridge, and that disrupts the whole network, and boom, it's a whole lot of mess. That's where BPDU Guard comes in. It shuts the port down if it sees BPDUs, and if we enable BPDU Guard, so that's an easy protection for us when it comes to protecting the topology in terms of if any user unintentionally, accidentally plugs in any of its switches into the access ports. Next feature that we have is BPDU Filter. BPDU Filter is like the quieter cousin of BPDU Guard. It stops BPDUs from being sent or received. But you will see that this is not used in a very general environments. This is in a very specific use case. It's risky if it's misused. For example, you could be using BPDU filters when you are connecting from, let's say, a switch from where you don't want to receive any kind of BPDUs because you want this particular switch, local switch, to be the root bridge, let's say, and you are very much sure that the switch that I am connecting on the other port is not going to send any BPDUs, so I don't have to worry about it. Maybe it's an unmanaged switch or whatever the case could be. Then what are the different options that we have in terms of protecting the topology? What are going to be the best practices? So combine your PortFast with BPDU Guard for safe, fast edge ports. And again, don't forget RootGuard to prevent rogue root elections from keeping someone from hijacking your root bridge. So together, all these features lock down your STP design. Next is one of the issues that we see. If you have ever seen one-way communication on a fiber link, that's a unidirectional link, and STP won't know about it because it's unidirectional. So traffic keeps forwarding, and boom, broadcast is wrong there. Big headache. So to cache all those bad links, we use UDLD. It checks if both sides are still talking, and we have then the LoopGuard. It makes sure that the ports doesn't block suddenly and they start forwarding just because they missed a few BPDUs, right? So that's where we use UDLD. So that's STP in a nutshell, its role, features, and how we protect it. In the next video, we will level up. We'll talk about port channels, VPCs, which help with link aggregation and redundancy in Nexus switches. So don't miss it, and I will see you in the next video. Thank you for your time.